Hello, everyone. We're going to be doing section 3.2, which is on graphing linear equations in two variables. So in our last section, we focused on just finding these linear equations in two variables, and now we're really focusing on the graphing portion. So we have four objectives. One objective we are omitting, which is why there is a line through it. But our first objective is that we want to graph linear equations by plotting ordered pairs. Objective 2, we want to find intercepts. 3, we want to graph linear equations of the form y equals b or x equals a. And then 4, we want to use a linear equation to model data. So with objective 1, we just want to graph linear equations by plotting ordered pairs. So there are infinitely many ordered pairs that satisfy an equation in two variables, which is something that we touched on in our last section. So in our image here, we have the graph of the line x plus 2y is equal to 7. So what we're seeing here is that each one of our ordered pairs is a solution. So -1, 4 is a solution, 1 and 3 is a solution, 3 and 2 is a solution, 5 and 1 is a solution, and 7 and 0 is a solution. And since we see that in this line we have these arrows, we're seeing that these lines have arrows, and the arrows mean that they're going to go on infinitely. Since they're going on infinitely, this means that every point on the line in this picture represents a solution of the equation x plus 2y is equal to 7, and every solution of the equation corresponds to a point on the line. So this line is really representing every single possible solution of our equation x plus 2y is equal to 7. So this line gives a picture of all the solutions of x plus 2y is equal to 7, and it is the graph of the equation x plus 2y is equal to 7. So this is our graph of an equation. Graphing is the process of plotting ordered pairs and drawing a line, or sometimes curve, through the corresponding points. In our case, we're going to be working with lines. So the graph of a linear equation, or graph of any linear equation in two variables, is a straight line. And in order to plot our straight line or graph a straight line, all we need to do is find 2 points and connect those points. Notice there that the word line appears in the term linear equation. So when we talk about linear equations, we know that these are equations that when graphed will produce a line. So putting this into practice, example 1, we want to graph 2x minus y is equal to 4. And we have a little table set up for us so we can plot or put our ordered pairs into our table just for a little extra representation. And then we want to graph on our rectangular coordinate system that we see here, or our plane. So if we want to graph 2x minus y is equal to 4, we want to pick some x values. And these x values that we pick, we want them to be easy. We want them to not be decimals or fractions. And when finding these values, it is always helpful to pick a value of 0 because it is always fairly straightforward to solve. But let's go ahead and let's start at 0. Let's say that our x terms that we want to test out are going to be 0, 1, and 2. And we're picking 3 instead of just 2 points because we only need 2 points to really graph a line, but we want to get that third in just to check and make sure that it is a straight line. Because if it turns out that one of your points is off center of where your line should be, then maybe there were some errors in your solution and maybe you should go look over it again. So we include this third point just as a little bit of a check. And if it's correct, they should all fall on that line. So let's go ahead and label these. So let's say that our x value of 0 is our first equation that we're really solving for. X equals 1 is going to be our second, and x equals 2 is going to be our third. And this is just to keep our work straightforward and separated out. So starting with our first x value, we're saying that x is equal to 0. And remember, we're going to plug this into our original equation. So we're going to plug in x equals 0. So in our equation, 2x minus y is equal to 4, we're plugging in x equals 0. So we have 2 times 0 minus y is equal to 4. Well, 2 times 0 is just going to be 0. And 0 minus y is just going to give us a negative y. We have a negative y is equal to 0. We know that the property states that if we had a negative variable equal to some number, that variable is equal to the negative version of that number. Or we could go ahead and multiply each side by, let's say, -1 or divide by -1. Either way, we can still get rid of that negative in our variable. So let's go ahead and divide by -1, which in this case gives us y is equal to -4. So when x is equal to 0, y is equal to -4. So we would fill in this spot on our table. We can draw a little arrow, and we know that this now represents the ordered pair of 0, -4. And now for our second x value. Our second x value, we are going to plug in x equals 1 into our original equation. So now we have 2 times 1 minus y is equal to 4. 2 times 1 is going to be 2, minus y is equal to 4. Well, we want to get rid of that 2 to isolate our y term, so let's subtract 2 from both sides. So we get 2 minus y minus 2 is equal to 4 minus 2. 2 minus 2 is 0, so we have 0 minus y is equal to 4 minus 2, which is 2. 0 minus y just gives us negative y is equal to 2. And using our property, we know that a negative variable equal to some number is just the positive variable equal to negative version of that number. So y is equal to -2. So when x equals 1, y is equal to -2. And this gives us our ordered pair of 1, comma, -2. And then lastly, our last x value here is x equals 2. So we plug x equals 2, plug in x equals 2. So we're plugging in x equals 2, so 2 times 2 minus y is equal to 4. Well, 2 times 2 is going to be 4, minus y is equal to 4. We subtract 4 from both sides. This gives us 4 minus y minus 4 is equal to 4 minus 4. Which now this will give us 0 minus y is equal to 0, or negative y is just equal to 0. So this means that y is just equal to 0. 0 can be negative, so we can drop our negative symbol in front of our variable at this point. So we get y is equal to 0. So when x is equal to 2, y is equal to 0, and our ordered pair is 2, comma 0. So we have our 3 ordered pairs. Now we want to graph them. Starting with our first ordered pair, 0, -4. And let's, we'll plot them in red. So 0, -4, we want to plot on our graph. So our x value is 0. So we begin at the x value 0. And then -4, so we're going to go down 4 and plot our point. And this point here is 0, -4. Then our next point is 1 and -2. So we find our +1 on our x-axis here, which is right here. And we go down to -2. And we plot our point. And this point here is 1 and -2. Then lastly, we have our ordered pair of 2, 0. So our x value is 2 and our y value is 0. So we find our x value, which is 2 on our x-axis. And since the y value is 0, we just plot that point on that axis there. And this is our point 0, 2. So we've drawn our points here, and now we want to draw a line. And we see that our line in this case is going to cross through all 3 of our points. And it is as straight as a line as I could have drawn. We see here that each one of our ordered pairs would be a solution, and our line that we've now drawn would represent all of our solutions there. All right, so objective 2, we want to find intercepts. The point where our solution line crosses an axis is called the intercept. The x-intercept is the point where the line crosses the x-axis, and the y-intercept is the point where the line crosses the y-axis. And if you've noticed, in our last problem, we identified both our x-axis, our x-intercept, and our y-intercept. These are our spots where our line crosses the x and y axis. So finding an intercept, to find the x-intercept, we want to let y equals 0 in the given equation and solve for x. Then x comma 0 is the x-intercept. Then to find the y-intercept, we let x equals 0 in the given equation and solve for y. Then 0 comma y is the y-intercept. So all we need to do to find them is plug in 0 for the other variable that we're not trying to find. So if we're trying to find the y-intercept, we plug 0 into x. If we want to find the x-intercept, we plug 0 into y, and then we just solve. So for example 2, we want to find the intercepts of the equation and draw the graph. So once again, we want to have 3 separate points just because we want to make sure, but we know that our x-intercept and our y-intercepts will be found by plugging 0 into the opposite variable. So our first value in our graph here, or in our table, for x, let's just go ahead and put 0. We want to find that y-intercept. And then let's say in our last spot, we plug in 0 for y. And we're going to find that x-intercept. And then we're going to find a value in between. Let's go ahead first and solve for our y-intercept. Then second, we'll solve for our x-intercept. And third, we'll solve for some value in between. So first, we plug in x equals 0 to find the y-intercept. So our equation is x minus y is equal to 3. So 0 minus y is equal to 3. This gives us negative y is equal to 3. So y is just equal to negative 3. We can fill this spot in on our table. So when x is equal to 0, y is equal to negative 3. So our point here is going to be 0, comma, negative 3. And we've identified that now our y-intercept is at 0, negative 3. And now for our second calculation here, we're going to find our x-intercept. So we're going to plug in y equals 0 to find the x-intercept. So our equation was x minus y is equal to 3. So x minus 0 is equal to 3. So we get that x is equal to 3. So we fill in our table. So we say 3 is at x value, and our ordered pair is 3, comma, 0. And our x-intercept is found at 3, comma, 0. Then lastly, this last calculation, we just want to find some value in between. And we want to make it easy for ourselves. So let's go ahead and we're just going to make x 1. And now we're going to solve for y. So we plug in x equals 1. So our equation x minus y is equal to positive 3. We're plugging in 1 for x, so we have 1 minus y is equal to 3. And now we want to solve for y. So let's go ahead and subtract 1 on both sides. We get 1 minus y minus 1 is equal to 3 minus 1, which gives us negative 3 is equal to 2. Yep. So we just get that y is equal to 2. So we can fill this into our table, and this gives us our last ordered pair of 1, comma 2. And now we can plot these points on our graph. Let's start by plotting our intercepts. So we can start by plotting our y-intercept, which is at 0, negative 3. So our x value is 0, so we started at our origin, and we track down to negative 3, and we put our point there. We say that this is 0, negative 3, our y-intercept. Then our x-intercept is going to be 3, comma 0. So since 3 is our x value, we track over to 3, and we stop there because our y value is 0. Say this is 3, comma 0, or our x-intercept. Then our point in the middle. Our point in the middle is going to be at 1, 2, so our x value starting at the origin is positive 1, and then we can track. I just realized I forgot the negative. I apologize. Y is equal to negative 2. It's like, this isn't correct. So it's 1, negative 2. Good job if you caught that. If not, it's okay. I forgot it too. So all right, our point was 1, negative 2. So we track over to positive 1 on our x-axis and down negative 2. And this value here is 1, negative 2. And now we just want to connect our points and make sure that all of our points lie on the straight line. We're just drawing as straight as we can. We see that they are. I'll draw a little arrow there. So all of our ordered pairs fall on our graph of our equation, which was just that line there. So when you want to draw your graph of an equation, it is a lot of the time easiest to solve for your intercepts and then just solve for some value in between. When you're solving for your intercepts, you're just plugging in 0, so it makes a straightforward calculation fairly easy. And then you just want to actually solve for some point that lies in the middle. So you can just make sure that it is going to fall on that line.